Right, the second part of 6.2 is about undoing the chain rule to solve indefinite integrals, and it's a method for undoing the chain rule. You are responsible for knowing this method, and you have to be able to show the College Board that you know how to do it. But there are some people who can really just see U-substitution and kind of do it in their head. I'm going to give you the method because this works all the time if you can choose the correct U that you replace. Okay, so here's our first example. We're going to go through the process as we go through this example. I'd recommend pausing and writing down the example if you haven't already. And you might even want to rewrite it so that it has exponents. So your first step is you're going to set U. And the way you set U is you look for what was the baby before you took a derivative, and that's what your U is going to be. It looks to me like we had sine of x as the baby. So I'm going to say U equals sine of x. And the reason I chose sine of x is because I had the square root of it, and also because I can kind of see the derivative of sine of x hanging out. The next thing you're going to do is you're going to find dx. The way we do that is we're going to take the derivative of u. So the derivative of u, du dx, is cosine of x. But we have to solve for dx. So I'm going to multiply both sides by dx. So du equals cosine of x dx. And so dx equals du over cosine of x. Okay, the next thing we're going to do is a double substitution. We're going to substitute the baby and, with the u, sorry. And we're going to replace our dx. So we're going to replace dx, and we're going to substitute our baby in. So it's going to look like this. It's going to be the integral of u to the 1/2 power times cosine of x times, and dx is equal to du divided by cosine of x. What we notice is that our cosine of x's cancel, so we're left with the integral of u to the 1/2 du. Now we're going to solve the integral. I want to make a note here that your integral should always look at this point exactly like something on your bright yellow sheet. If it doesn't look exactly like something on your bright yellow sheet, except spelled with u's instead of x's, then you haven't made the correct u substitution. So you haven't chosen the correct baby in step 1, or you've made a mistake somewhere along the way. You should no longer have any x's. It should all be in terms of u, and it should look exactly like something on your bright yellow sheet. This one looks exactly like the power rule, so I can add 1 to the exponent, so it becomes u to the 3/2, and divide by 3/2, or multiply by 2/3, and then make sure I have a plus c. Okay. Now I'm going to translate back because I was given a problem with x's, so my answer should be in terms of x, not u. So my final answer should be 2 times sine of x, which was what u was, to the 3/2, divided by 3 plus c. So that is the thing that gives me this for a derivative. If I took a derivative of my answer, I should get back to where I started. Okay, that's our process. We're going to go through a couple of examples, and I would recommend that you write them down and try them yourself before I do. If I can get this. All right, here's our first example. Remember, the first thing you want to do is figure out what u was, and then you want to set u, and then you want to take a derivative of that and solve for dx. I'll give you a minute to try this problem. All right, now my solution would be u is equal to x to the 5th, because the baby is x to the 5th. The derivative of that is 5x to the 4th. So dx would be du divided by 5x to the 4th. Okay, now I'm going to do my replacement. So cosine of u times x to the 4th times du over 5x to the 4th. My x to the 4ths cancel. and I have 1/5 cosine of u du. And except for the 1/5, which is just a constant, I now have something that looks exactly like what's on my bright orange card. The antiderivative of cosine is sine of u. I still have a 1/5 and a plus c. That's not my final answer because that's in terms of u. So it was like my question was in English and I'm answering in French. I want to translate back to English. So I have sine of x to the 5th plus c. That's my final answer. If I take a derivative of sine of x to the 5th, 1/5 sine of x to the 5th, I wind up back where I started. All right, here's another example. Pause the video, see if you can figure out the answer to this one, and then come back and I'll show you the solution. So I would make u equal to x squared plus 2, and so du dx would be 2x. So dx would be du divided by 2x. So if I rewrite this integral, I'm going to write it with negative exponents. I have u to the negative 3rd times x times du over 2x, because I replaced my dx, and I replaced my x squared plus 2 with u. Now my x's cancel, which is good news, and I have 1/2 times u to the negative 3rd du. Except for the 1/2, it looks exactly like something on my sheet, so I have 1/2 u to the negative 2 divided by negative 2 plus c. So my final answer is negative 1/4, and then I want to replace my u with x squared plus 2 to the negative 2 plus c. If I take a derivative of this answer, I should get that integral. All right, here's one where it looks like I have 2 babies. That's kind of weird. So I'm going to say, I'll give you a minute, pause if you need to. All right, so for my solution, I would say u is equal to x squared. Du dx is equal to 2x. So dx is equal to du divided by 2x. So then I rewrite this as secant u tangent u times x times du over 2x. My x's cancel, so I have the integral of 1/2 secant u tangent u du. Except for the 1/2, it looks exactly like something on my sheet now. So my antiderivative is secant of u. And then I can replace the u to make my answer be in English. So I have 1/2 secant of x squared plus c. All right, here's a challenging one. So one thing that you might get used to doing is making yourself see that it looks like something on your sheet already, except for one thing. So if I rewrite this a little bit, I have dx is equal to the square root of, my sheet wants this to be something squared, right? So what if I rewrote this as quantity 3x squared? Do you see how 9x squared is equivalent to 3x squared? So now my baby is 3x. My derivative is going to be 3. So dx is equal to du over 3. And so I have du over 3 times the square over the square root of 1 minus u squared. Now it looks like sine inverse. I have a 1/3 times sine inverse of u plus c, but I want to replace the u, so I have 1/3 sine inverse of 3x plus c. All right, I think we'll do one more. Okay, so we can sometimes do definite integrals this way as well. When we do definite integrals, it's similar. There's a kind of a trick we can do. As I'm looking at this problem and just thinking about it a little bit, it might be that 1 plus x to the fourth would be the u, but the derivative of x to the fourth is not there. X to the third is not hanging out. So what if this actually looked like tangent inverse instead? So what if I rewrote this a little bit? So it was going from 0 to 1 of x over 1 plus x squared squared dx. And now do you see how it kind of looks like tangent inverse, and the derivative of x squared is hanging out. So I'm going to make, oops, this is a negative 1. I'm going to make u equal to x squared. So the derivative of that would be 2x. So dx is equal to du over 2x. And here's the trick with definite integrals. Remember I talked about you have to translate back to Spanish and you have to, or to French, and then you translate back to English. Well, the other option is you can teach your limits of integration French. And so right now my limits of integration are x coordinates, and I could teach them French and change them into u coordinates, and then I don't have to go through the whole process of changing back. So that's what I'm going to do. So one of my limits of integration is going to be negative 1 squared, and the other limit of integration is going to be 0 squared. I'm just teaching my limits of integration French. So my limits of integration are going to go from 0 to 1. And then if I rewrite this, I have x over 1 plus u squared, and then dx is du over 2x. My x's cancel. I have a 1/2, and I have tangent inverse of u. And remember, for these ones, we find the antiderivative, and then we plug in the limits of integration. And we don't need the plus c, because it can be any antiderivative. So if I do a 1/2 tangent inverse of 1 minus 1/2 tangent inverse of 0, I'm looking for the angle that gives me a tangent of 1. So it'd be 1/2 times pi over 4. And then the angle that gives me a 0 would be a 0, because sine over cosine, and sine is 0. So this is my final answer. I could write that as pi over 8 as well. So remember, you can teach your limits of integration French, and then you don't have to worry about translating for them.